Hello students, welcome back to Turning Point classes. In today's session, I discuss Kcet questions related to the third chapter of second PU physics. So in today's session, I discuss the first level questions. Let us start. The smallest resistance obtained by connecting 50 resistors, each of 1 by 4 ohm, is 4 options are given. We learnt when resistors are connected in parallel, effective resistance is less than the smallest resistance of the combination. Now, to obtain smallest resistance, you should connect resistances in parallel. Now, we use the shortcut formula which is available when resistors are in parallel, R subscript P is equal to R by N. R is the resistance of each resistor. Of course, here it is given that 1 by 4 ohm is the resistance of each resistor. There are 50 such resistors, 1 by 4 by 50, that gives us 1 by 200 ohm. Option D is answer for this question. Now come to the second question. In the second question, the resistance across M and N, if each has a resistance of R ohm is. So this is a circuit diagram given. Now you just observe this circuit. Between M and N, we have to find the resistance. Find out. Just you view this circuit diagram. Here, these two resistors are in parallel between the same 2 points. So between this point and this point, both the resistors are connected. Of course, they are all connecting wires. So I can replace these two resistances which are connected in parallel by R by 2 by using this Rp is equal to R by N. Effective resistance. When n identical resistors, each of resistance R are connected in parallel, effective resistance R subscript P is equal to R by N. These two are in parallel, these two are in parallel, these two are in parallel. So we can replace this by R by 2 here. This part is also R by 2. Here also it is R by 2. Now I retain the point M. This point is N as it is. Fix these 2 points in mind. Look at the remaining part of the circuit. So these two look to be connected in series. In series combination, effective resistance is given by sum of the resistances. R by 2 plus R by 2, that gives us R. So this is equivalent to, here we have R by 2 as it is, R by 2 plus R by 2, that gives us R. Now these two are in parallel. So parallel combination, Rp is equal to R1, R2 divided by R1 plus R2. If I simplify this, R1 I will take as R, R2 is R by 2 divided by sum of the resistances R plus R by 2. Simplify this. So this is equal to, of course if I take LCM here, that's 2 and LCM whatever you get 2 cancels. So we have R square divided by, so here if you take LCM you get 3R here. This is nothing but when R gets cancelled, R by 3. This is answer. So B is answer for this question. Coming back to the third problem, the resistance between the points A and B in the circuit is. Now we are given a circuit of this type. So if you connect one battery between A and B, there won't be any flow of current through this point, even through this point, because these resistors are open resistors. So the circuit is not closed. Current flows only when the circuit is closed. So this is an open end. This is also an open end. Therefore, there won't be any flow of current. This one, you can simply delete them, ignore them. They are simply dummy resistors. So remove this. Now, once we remove, I take A as it is. This resistance I retain this time. Even this resistance will also be there. I write one more simple reduce the circuit now, it will become easier for us to understand. Now if you observe this part, so if you observe these 2 points, between these 2 points, these two 10 ohm resistors are in series. 10 plus 10 series combination. Effective resistance is given by 10 plus 10, that is nothing but 20 ohm. Similarly, on the lower side also, between between the same 2 points, 10 ohm and 10 ohm, they are in series. That series combination will give us the effective resistance of 10 plus 10, that is nothing but 20. So here we have 20 ohm resistance, there is also 20 ohm resistance between the same 2 points. When two identical resistors connected in parallel, effective resistance is given by Rp is equal to R by N. So here we have 20 ohm, here also 20 ohm. 20 in parallel with 20 gives us a 10 ohm effective resistance. That means between these 2 points I can replace it by 10 ohm. Once I put 10 ohm here, this 10 ohm plus that 10 ohm, one more 10 ohm here. So in total there are 3 resistors connected in series. This will give us 30 ohm. So that is the answer. Very shortcut method. This is how we have to do it. The next question is the current in the circuit is. So this is a circuit diagram given. It's a simple circuit. So if you observe between these 2 points, this point, 30 ohm, they are in series. 30 and 30 in series will give us 60 ohm. 30 plus 30, that is 60. That 60 is in parallel with 30 ohm. Straight away you find what is the effective resistance of 60 in parallel with 30. Effective resistance we learned Rp is equal to R1 R2 divided by R1 plus R2. There is a formula what we have. If I substitute, so here we have 30 plus 30, that is 60. In parallel with 30, that is 30 divided by 60 plus 30, that is 90. 60 into 30 divided by 90, this gives us 20 ohm. So Rp is equal to 20 ohm. Now I want to find what is the current. Current I is equal to EMF divided by external resistance plus effective internal resistance in case it is there. Nothing is given. So therefore E by R. So EMF is given as 2 volt divided by 20 ohm, that gives us 1 by 10 ampere. So this is the answer for this question. So it is there in option C. In the next question, the current in the circuit shown is just observe the circuit diagram. So this is the current I. Here there is a flow of 2 ampere current. Now we have to find out what this current is. So 2 ampere is flowing here. Here there may be some current. We don't know. That current if we can find out, that current plus 2 ampere current will be I. But we learnt that resistors are in parallel. Potential difference is the same. So that is the idea what we use here. So this 6 ohm resistor and 3 ohm resistors, they are in parallel. Potential difference remains constant. So therefore I use PD across, only for our understanding I am writing this and directly we can do it. PD across 3 ohm and 6 ohm are equal. So 2 ampere into 3, 2 ampere into 3 ohm. So this is the potential difference here. Here let me call that current as I dash. This is equal to, so here I dash times 6 ohm. So potential difference across this resistance, potential difference across this resistance remains the same. Potential difference is given by current into resistance. Here we don't know what the current is. I will take it as I dash is the current flowing through this I dash into 6 ohm. Simplify this. So if you take left hand side, that is 6 bring it to denominator, it cancels. So we will get I dash is equal to 1 ampere current. Once we found I dash is equal to 1, so this current through 6 ohm is 1. Here 2 ampere is flowing, Kirchhoff's laws. Incoming current is equal to sum of outgoing currents. So the main current I is equal to, therefore I is equal to 2 ampere plus 1 ampere. 2 ampere plus 1 ampere, that is equal to 3 ampere, which is there in option A. So A is answer for this question. Coming to next question, in the circuit diagram shown below, the magnitude and direction of the flow of current respectively would be. So we are given one circuit diagram. Find out first what is the current. To find the current, just observe the 2 cells which are given here. The EMFs of these 2 cells are in opposition. So the EMF of 10 volt, this direction, the other one is towards left direction. EMF is taken from positive terminal to negative terminal, EMF. So if you take this positive to negative, this one is positive to negative, Here this is 10 volt. When cells are connected, they are not connected in series, but one wrongly connected. Cells are in series, provided positive terminal is connected to negative terminal and so on. But that is not the case here. So what we do is you take net EMF here. So net EMF is 10 volt, 4 volt. So 10 volt EMF is this direction. There is a direction of EMF of 10 volt. So this direction is opposite towards left. So therefore net EMF, if I find 10 volt minus 4 volt, that is equal to 6 volt. Once I find EMF, current is very easy. Current I is equal to EMF divided by external resistance, effective external resistance. So EMF is 6 volt divided by resistance. All resistors are in series now. So this is 1 ohm plus 3 ohm plus 2 ohm. That gives us 6 ohm. This gives us 1 ampere current. So 1 ampere current, which direction is it? So this is the direction of the EMF in this case. Here in this diagram, EMF is in this direction. So this is more compared to the other one. So therefore, current is flowing in this direction. So that means from A to B current flows. So EMF, whichever has got more EMF, in the direction of more EMF, current flows. So current is flowing from A to B. That is the answer. Option D is answer for this question. If you have not watched our previous videos, link is available. Go to that link and view all previous videos available. If you are not subscribed to Turning Point classes, subscribe to Turning Point classes. Share the link with your friends. Like the video. We'll come back to next class. God bless you.